Hello student, in this video we will cover CBSE class 10th physics topic which is electricity. So in electricity chapter we will discuss about the electric current, electric potential and potential difference, electric circuit and diagram, Ohm's law, resistance of a system of resistors, heating effect of electric current and electric power. So first, we will start with the electric current. So in electric current, we first focus on introduction of this chapter. So first thing that we have to know is charge. Charge is a property of matter. So what is the meaning of property of matter? Property of matter means if we take any matter around us, it must have charge present. Like we say that if we have any matter, then it must has mass. So same way, charge is also a property of matter. It means that if you take any material or any matter around us, there must be a charged particle present inside it. Charge is divided into two types. First is positive charge. Second is negative charge. Positive charge is carried by proton. An electron carries negative charge. So you might think that if we have any matter around us has a property charge, so why not we are getting any shock? The reason behind this, if we take any object and this object, if we have positive charge and negative charge of same amount, as you see in this figure, we have two positive charge and two negative charge. So total charge will be plus 2 and minus 2. So it is equal to 0. So in this matter, charge is present, but total charge is 0. So that's why when you touch the book, you will not get any shock or any other material. The reason behind that is same number of electron and same number of protons are present. But if you take two different body, like this is body A and this is body B. So inside body A and body B, if we take positive negative and this side positive negative, so this is also neutral. Why it is neutral? Because number of electron and number of protons are same. This is also neutral. Now if these two body, if we start rubbing with each other, like this body B comes near to A and here we rub it, so what will happen? Few of the electron will move from B to A or A to B. From anywhere, electron will move. Always remember, only electrons have property to move from one place to another place. Protons will remain as stationary. Okay. So here, if we consider these two body now touching at this point, or we can rub it, electron will move from any one of the body. Suppose if A will move the electron to B. So then what will happen? Initially, A had 3 proton and 3 electron. Now, after rubbing, body A has 3 proton and 2 electron. So due to that, what will happen? Body A will become positive charged and body B initially 3 proton, 3 electron. Now it will become 3 proton and 4 electron. So it will become negatively charged. So after this A and B will become separated, A becomes positively charged and B becomes negatively charged. So from here we can conclude that all the matter has charge due to the presence of electrons and protons, but due to the rubbing there is a transfer of electrons takes place, and then one of the body will become positive charge and another will become negative charge. Sometimes in the dry climate when we comb the hair, so we feel that the hair start attracting towards the comb. So initially it was not attracted, but due to the rubbing, due to the combing, what happened? It forms a charge on both the body. So due to that, they start attracting with each other. So here we can write a statement. So here we can say that like charges repels and unlike charges attracts. So we got idea about the charge. Now we will study about the unit of charge. The SI unit of charge is coulomb. It is represented as capital C. So if we have one electron, it will carry a charge of minus 1.6 into 10 to the power minus 19 coulomb. And if we have a proton, it will be plus 1.6 into 10 to the power minus 19 coulomb. So electron and proton both has same magnitude of charge. Only the positive and negative sign will change. Here, this plus and minus is just a conventional representation of electron and proton. In mathematically, if we write plus 1.6, it means that we are talking about the proton. And if we write minus 1.6, it means we are talking about electron. So this coulomb is very big unit. How it is a big unit? I will explain you with an example. In this question, find the number of electrons present in 1 coulomb of charge. Means we have to find how many electrons are present in 1 coulomb of charge. So one point, always remember, electron is the smallest unit of the charge. It means that nothing is more or smaller than the charge of electron. If we have to find the total charge is equal to number of electron into charge of one electron. So if our total charge is Q, Q is equal to N is the number of electron into charge of one electron. So Q is equal to N into E. So in this question, total charge is given as 1 coulomb. And we know that charge of one electron is 1.6 into 10 to the power minus 19 coulomb. So if we substitute the value, 1 coulomb is equal to N into 1.6 into 10 to the power minus 19 coulomb. So from here, number of electron is equal to 1 divided by 1.6 into 10 to the power minus 19 coulomb. If we solve it, it will come 6.25 into 10 to the power 18 electron. So you see that in 1 coulomb, 6.25 into 10 to the power 18 electrons are present. So it's a very big unit. The number of electrons are very big number. So that's why 1 coulomb is a big unit, because it contains lot of electrons. I hope you understood this point. So let's move to our topic, electric current. Electric current is defined as rate of flow of charge. Means how much charge flows in the given time is defined as electric current. So electric current symbolically represented as I. So I is equal to charge upon time. So I is equal to Q by T. This is a formula of finding the current. So this can also be represented as I is equal to N into E divided by T. Because we know that total charge is equal to number of electron into charge of one electron. The SI unit of current is ampere. It is represented as capital A. So how we can define 1 ampere? When 1 coulomb of charge flows in 1 second of time, then it is said to be 1 ampere. So we know that I is equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. And the SI unit of time is second. So 1 ampere is defined as when 1 coulomb of charge moves in 1 second. Then it is said to be 1 ampere. So 1 ampere is equal to 1 coulomb per second. Sometimes we are using a smaller units of current like 1 milliampere. So it is equal to 10 to the power minus 3 ampere. This is 1 milliampere. Similarly, 1 microampere is represented as mu and A. It is equal to 10 to the power minus 6 ampere. Many times a student knows the formula but they don't know the conversions. How to convert milliampere to ampere. So that's why even knowing the formulas, knowing the values, they are not getting the correct answer because our answer should be in the SI unit. So the SI unit of current is ampere. So if the question gives 1 milliampere, then we have to convert to ampere, or even if it is microampere, we have to convert to the ampere. So that's why these are small conversions we have to remember. Ammeter is used to measure the current. Ammeter is an instrument through which we can measure the electric current by placing it into a circuit. Through that we can measure the how much current is moving in a circuit. So here you see this is the picture of the ammeter and how ammeter is connected in the electric circuit. So this is the ammeter connected to the wire. This is the battery and here is the load. Through that we can find the how much current is passing through the circuit. Now we will try few questions based on electric current. In this question, a steady current of 5 ampere flows through a circuit for 30 minutes. How much charge has been circulated through the circuit in this time? So according to the question, given value is current 5 ampere and the time 30 minute. So minute is not our SI unit. We have to convert to second. So it is 1800 seconds. And we have to find the charge. Q we have to find. So we know that total current is equal to charge upon time. This is our formula. So from here, charge is equal to current into time. So charge is equal to current into time. It will form Q is equal to 9000 coulomb. This is the answer. In this question, a current of 1 ampere is drawn by a filament of an electric bulb. Number of electrons passing through the cross-sectional area of the filament is 16 seconds. So how much electrons are present? These are the four options given. We have to find which option is correct. So let's solve this. So here, according to the given question, current is considered as 1 ampere. Time is 16 second. And we have to find the number of electron. And we have to find. So previously I explained you the formula of current. I is equal to Q by T. And based on that, I derive one more formula. I is equal to NE by T. So in this question, we have to find the N. So current is 1 ampere. N we have to find. Electron charge is 1.6 into 10 to the power minus 19 coulomb divided by 16. So from here, N is equal to 16 divided by 1.6 into 10 to the power minus 19 coulomb. 1 into 10 to the power 20 coulomb. So N is 10 to the power 20 coulomb. This is the answer. So which option is matching? Option number A. Now we will study about the electric potential and potential difference. So here in this figure, this is a charge plus Q. Its magnitude is more than the test charge. Test charge we can consider as positive but very small charge Q. It means that the influence of this test charge is not affect the bigger charge, and this is fixed here. So what happen if it is a positive charge? So it has a certain range till where it can attract or repel the other charge body. So the dotted line that you notice it here, it's a sphere, it represents the electric field. Or in a simple language, you can say that this is the area till where the influence of the bigger charge is present. It means that if we put any test charge or any other charge in this range, then this fixed charge start repelling this test charge. But when any test charge is outside this sphere, so there is no attraction or repulsion by the fixed charge. So if any test charge which is outside this electric field is considered at infinity, means right now this test charge is present at infinity. So what we need to do? We need to move this test charge from at infinity to a certain point which is inside the electric field line, like here. But here is a problem. It is not possible. Why? Because when this test charge will about to reach the surface of the electric field, then this fixed charge start repelling it. Means if we have to reach it here, then it is not possible. And if it is possible, then we have to apply some external work on it. So if we consider this point as A, and we have to move the test charge from infinity to A, so we have to do certain work. So this work is depends upon the magnitude of the test charge. If the magnitude of test charge is more, we have to do more work. If the magnitude of the test charge is less, then we have to apply the less work. I hope you understood this point. So now we can define electric potential. Electric potential is basically a relation between work and charge. The amount of work required to move a test charge from infinity to a point A is defined as electric potential. It is represented as capital V. So electric potential formula is work done divided by charge. So here symbolically we can represent it as V is equal to W by Q. So what is the SI unit of the electric potential? SI unit of electric potential is volt. It also represents as capital V. So here the symbol of electric potential and the SI unit of electric potential both has same unit. So how we can define 1 volt? When 1 joule of work is required to move 1 coulomb of charge, then it is defined as 1 volt. So here 1 V is equal to 1 joule in 1 coulomb. So 1 V can be written as 1 joule per coulomb. Joule is the SI unit of work and coulomb is the SI unit of charge. So how we can define electric potential difference? If a test charge is present at infinity and it reaches to the point A, so that time the potential is VA. Similarly, when the test charge at infinity reaches to point B, then it is potential at B because both are starting from infinity. This one has potential VA and here is a potential VB. So potential difference is the difference between two potential. Means we can define it as the amount of work required to move a test charge from point A to point B. So if we write potential difference between AB, it is written as potential at A minus potential at B. So practically, if I say there is no difference between electric potential and electric potential difference, both are similar. Why? Because their formula is same, their SI unit is same, and their symbols are also same. Only the difference is electric potential we always consider from infinity to point A or B, but electric potential difference is the difference between two points, point A and point B. This difference is electric potential difference. I hope you understood this part completely. Voltmeter is used to measure the electric potential. Electric potential is also called as voltage. So if you take a battery, as you see in this figure, it's a battery, and battery has two end. One is positive end and second is negative end. So this positive end, it has certain potential, and negative end has certain potential. So net potential difference in the battery is V plus minus V minus. So when this potential at both the ends are equal, then it means that the battery is dead. Because without potential difference, battery will not work. There must be certain potential difference present between the battery. You might see that when you use a battery after using for certain days, it's not working. It means that both the ends potential is same. So the potential difference is zero. So I hope you understood the importance of electric potential and electric potential difference. This is a figure of voltmeter and how the voltmeter is connected in the circuit. So you see that this is the battery and it has a positive and negative end. So current is moving from positive end, and then at these 2 points, two ends of the voltmeter are connected. This type of arrangement is called as parallel arrangement. Later we will study about it, but here you can note it down. Voltmeter is connected in the parallel arrangement. An ammeter is connected in the series arrangement. We will study later about this series and parallel arrangement. Now we will solve few questions based on this electric potential and potential difference concept. So here is one question. In this question it is mentioned that a charge of 1.6 into 10 to the power minus 3 coulomb is moved from 2 points and 3.2 joule of work is done. What is the potential difference between the 2 points? So in the question it is given that the test charge value is 1.6 into 10 to the power minus 3 coulomb and the work done is 3.2 joule. We need to find the potential difference. So potential difference formula is V is equal to W by Q. So if we substitute the value, W is 3.2 and the charge is 1.6 into 10 to the power minus 3. So it will come as 2 into 10 to the power 3 volt. This is the answer. In this question, electric potential at a point in an electric field is 100 volt. How much work will have to be done to move the electron from that point to just outside the field? The magnitude of the charge on the electron is 1.6 into 10 to the power minus 6 coulomb. So the question try to say that if we have any charged body and this charged body has certain electric field and inside this charged body an electron is present, we need to do a work to move this electron from inside of the electric field to the outside of the electric field. So we know that plus and minus charge attracts each other. So if we need to move this electron outside the electric field, we need to do certain work. So this work we have to find how much work we need to require to move this electron outside the electric field. So we know that V is equal to 100 volt and the charge of one electron is 1.6 into 10 to the power minus 19 coulomb. So V is equal to W by Q. So from there, W is equal to V into Q. So 100 into 1.6 into 10 to the power minus 19 coulomb. So it will become 1.6 into 10 to the power minus 17 joule. So this much work is required to move the electron outside the electric field. Now we will study about the electric circuit. So electric circuit is defined as a continuous and closed path of an electric current. As you see in this figure, we have three cell of batteries. It is connected through a wire, and here is a bulb. But at this point, it's a switch. This switch is not connected. So if it is not connected, it means that circuit is not complete. So the current is not passing through it. But in the same way, if we connect the switch here, so then current is passing through it. So now it forms the electric circuit. So when the electric circuit is complete, then current can pass through it. Now I will explain you about the conventional direction of current. As you see in this figure, we have a battery, and battery has two terminal, positive and negative terminal. Conventional direction of current says that the direction of current will be from positive terminal to the negative terminal of the battery. It means that the current always move from positive to negative direction. But the question is why it is called as conventional direction of current. The reason behind this, as I told you in the beginning, when we were studying about the electric charge, there I mentioned that electrons can only move from one body to another body. Protons remains at rest. So same here, if this is the negative terminal of the battery, so electron will move from negative to positive. And the direction of electrons should be considered as the direction of current. But what happened previously, scientists thought that protons are responsible for the formation of the charge. Means protons are moving from one body to another body. That time electrons were not discovered. So they considered protons, which is a positive charge, as the moving charge. So that's why protons are present on the positive terminal. So positive terminal, from here the charges are moving. But later they found that no, electrons are responsible for it. But they didn't want to change this because many conventions were already formed based on this logic. So that's why it is called as conventional direction of current. So always remember, electron move from negative to positive, but current moves from positive to negative. Now we will see the symbols used in the electric circuit. This is a table of symbol of electric component. Here, electric cell is considered as one bigger line and one smaller line. Bigger line has positive charge and a smaller has negative charge, and there is a gap between it. Means we can't draw a figure like this way and we can't connect it. So it is always bigger line for plus, a smaller line for minus, and we put plus and minus. If we have a two cell battery, then we will continue it. This is a one cell, we'll follow like that. So how to remember? First plus, then minus, then again plus, and then minus. If you have to make a three cell battery, plus, minus, plus, minus, plus, minus. The combination of two or more than two cells are called as battery. Next is switch. Switch is open when we are not putting any dot in between. Means you have to make a like this. In between there is no connectivity. In the closed one we put a dot. Same thing can also be represented as this is open circuit and this is the closed one. Now this is the wire joint where the two wires are joined with each other. This is the one wire and this is another wire. Both are joined with each other. Similarly, when the two wires are crossing with each other without joining, so we make a line and it will just cross over it. Next is electric bulb. Electric bulb, we make a symbol like this or simply the bulb figure. Next is resistor. Resistor we will study later, but for now you just remember the symbol used in resistor. It is a zigzag representation of a line. So it is called as resistor, and this resistor has fixed value. Second is variable resistor. Variable resistor is also called as rheostat. Rheostat has variable resistance. Sometime in exam they ask define rheostat. It is a variable resistance. So variable resistance, we first make a resistor figure and then over it we make a straight line, or the same way we make a resistor and we draw a line like this. Both are same way of representation of rheostat. I can also show you how this rheostat look like. This is a rheostat. So here you see this black part. This is movable. We can move it from left to right. So it has a specific range. It start from 0 to certain range it will go. So whatever you required, which resistance you required, you can move it and you can fix that value. So it is a variable resistance. Next is ammeter. Ammeter is the instrument used to measure the current and it is symbolically represented as A, and voltmeter is represented as V. So if in exam question comes, how we will do it? Let's try one question. In this question, we have to draw a circuit diagram of electric circuit containing a cell, a key, ammeter, and a resistor of 2 ohm in series with a combination of two resistors 4 ohm each are in parallel and voltmeter across the parallel combination. So we have a cell. So we can first draw a cell and here is a key. Key means switch and an ammeter, and there is one resistor of 2 ohm. These all are connected in series and there is two more resistor which is connected in parallel. So parallel resistor we can draw and a voltmeter across a parallel combination. So here we place a voltmeter and now we will connect the circuit. So this is the diagram of the given question. Here is the key, cell, ammeter. These all are resistor. I hope you understood till here everything. In this video, we have studied about the electric current, electric potential and potential difference, and electric circuit and diagram. In the next video, we will study about the Ohm's law, resistance, heating effect, and electric power. So do subscribe my YouTube channel, and if you face any type of problem, you can also comment me in the comment box. Thank you.